Okay. Have you ever had that like mini heart attack moment when you're on your phone doing something important? Maybe you're filling out a form or you're finally getting to read that long article you've been saving, or even just crafting the perfect witty reply and suddenly, boom, the app crashes. Or even worse, your phone decides to just completely restart on you.
Oh, yeah.
And you get that awful feeling of like, oh no, is all that work gone? Is everything I just did lost forever?
Yeah, it's the worst, especially when you're trying to learn something new.
Right. You're really trying to absorb information, not just scroll past it. You want things to stick.
Exactly. And that's precisely what we're going to unpack today.
That's right. We're going deep, really deep into the world of persistent storage on your mobile devices.
We've got a ton of great material here that really breaks down the different ways apps make sure your data doesn't just vanish.
Yeah, so think of it like this. We're going on a behind-the-scenes tour to understand how your phone and all those apps you use manage to remember things, even after you've closed them down or even powered off your phone completely.
Right. It's pretty fascinating stuff. And I think knowing how it works can help you get even more out of your phone, understand those little quirks and maybe even frustrations we all have.
Absolutely. So, what's in it for you, the listener? Why should you care about this?
Well, understanding persistent storage is kind of like becoming a more informed citizen of your digital world.
Definitely.
You'll get a much clearer sense of why some information is always there when you need it, while other things seem to disappear. And you'll also see just how clever developers have to be to solve this challenge of making data last.
And along the way, we'll uncover some of the trade-offs developers have to make. Sometimes it's about speed, sometimes it's about security or the amount of storage space used. It's all about finding the right balance for the kind of data that needs to be saved. Okay, so to give everyone a roadmap for our deep dive today, we're going to hit a few main areas. First up is serialization, which just the word sounds intimidating, but it's really all about how complex things in apps, those detailed characters in your game, or all the settings for your custom photo filter, how they're saved and restored.
It's almost like magic, but it's really just clever engineering.
Right. And then we'll move on to something called property files, which are more commonly known as shared preferences in the Android world.
Ah, yes, shared preferences. I spend way too much time with those.
I bet. And these are perfect for storing simple things, user settings, preferences, those little bits of info that personalize your app experience.
Like whether you prefer light mode or dark mode.
Exactly. And lastly, we'll tackle the bigger stuff. Your phone's internal storage and external storage.
The difference between internal and external can be a bit confusing, and we'll really try to break it down for you.
Yeah, and this will help you understand why some files stick around even if you delete an app, while others get wiped clean.
It's all about where those files live and how they're managed. Plus, we'll get into permissions and how you, the user, have a say in all of this.
Okay, perfect. So let's start with serialization. It sounds kind of like something out of a sci-fi movie, like turning people into beams of light.
Yeah, definitely not that, but the concept's still pretty cool.
But in the context of our phones, what's actually going on?
Imagine you're playing a game, right? And you've created this really detailed character. You've customized their looks, given them special skills, all that good stuff. Serialization is essentially like taking a snapshot of that character and all their attributes and then converting it into a format that can be saved, kind of like taking a 3D model and turning it into a 2D blueprint that can be stored in a file. Later, when you load your game again, deserialization takes that blueprint and reconstructs the original 3D character with all their details intact.
Oh, so it's like a super organized packing system, right? You're basically taking something complex and breaking it down into manageable pieces that can be put back together later.
Precisely. It's like taking apart a complex Lego model and putting all the pieces and instructions into a box so you can move it and rebuild it later.
Okay, that makes a lot more sense. So it's not just about game characters, right? This applies to all sorts of things apps need to remember.
Oh, absolutely. Think about a photo editing app where you've created a complex filter with multiple adjustments. Serialization can save all those settings so you can apply that exact filter again later without having to recreate it from scratch.
Or like a document you're working on that has formatting, images, all that stuff.
Exactly. Serialization helps save that entire structure so you can pick up right where you left off. It's even used to send data between different parts of your phone's system or even across the network, like when you're syncing data to the cloud.
I see. So it's like a fundamental building block for making sure things don't get lost, whether it's inside an app or between apps.
Totally.
And our trusty resources here point out two main ways serialization is done: serializable and parcelable. That kind of sounds similar, but what's the difference in your experience?
All right, so Think of serializable as the reliable old truck of serialization.
Okay.
It gets the job done. It's built into the Java language, which is kind of the foundation for a lot of Android development, so it's widely understood and supported.
So it's kind of the default option, the one that's always there if you need it.
Yeah, exactly. You just slap the serializable label on an object, and Java figures out how to save and restore it. It's like having a universal packing system that works for a wide range of objects.
And the beauty of it is that, from a developer's perspective, it's pretty simple to use.
Right. But like that old truck, it can be a bit slower and less efficient, especially when you need to move things quickly within the Android world.
Okay, so that's where parsable comes in, right?
Exactly. Parsable is like the sleek, high-speed train of serialization.
Nice. Much faster.
It's designed specifically for Android and focuses on efficiency, especially when apps need to exchange data quickly, like between different screens or components within the same app.
Gotcha. So serializable is a general-purpose option, good for many situations, but maybe not the fastest, while parcelable is the Android specialist, optimized for speed.
You got it. It's all about choosing the right tool for the job.
Okay, so let's zoom in a bit more on serializable first, since it's the more, let's say, traditional approach. What are some of the key things a developer, or even just someone curious about how their phone works, should know about serializable?
The main thing is that it leverages this mechanism called reflection.
Okay.
Reflection is basically Java's way of looking inside an object and figuring out what data it contains and how it's structured. So when you mark an object as serializable, Java uses reflection to automatically take inventory of all the important stuff inside that object and figure out how to save it in a way that can be restored later. It's like the system is taking a detailed scan of your object without you having to explicitly tell it what to look for.
So less work for the developer, but maybe a bit slower, because the system has to do this analysis, this scanning.
Precisely. And another thing developers need to be mindful of is versioning. What if an app gets updated and the structure of that saved object changes? Well, older versions of the app might have trouble loading those saved objects. It's like trying to put together a Lego model with instructions from a different set. Things might not quite line up.
Yeah, that makes sense. Compatibility issues.
Exactly. And the developer needs to think about how to handle those situations. Plus, all this automation, all this reflection, it can sometimes come with a bit of performance overhead. There are also some nitty-gritty details under the hood, like specific classes in Java, like object output stream and object input stream, that are used for writing and reading these serializable objects. And they use these methods called write object and read object to handle the actual saving and restoring of the data.
So it's a powerful system, but maybe not the most efficient, especially for those cases where speed really matters.
Right.
Which brings us back to parcelable, our speedy friend. What makes parcelable so much faster and more efficient, especially within the Android ecosystem?
With parcelable, instead of Java doing all the work behind the scenes through reflection, the developer takes more direct control. They basically write the code that tells Android exactly how to pack and unpack the data for that specific object. They create these instructions a bit like a custom packing guide that say, okay, take this piece of data, put it here, take that piece of data, format it this way, and store it over there.
So it's more work for the developer up front, but you get more control and efficiency.
Exactly. And Android provides this specialized container called a parcel, which is highly optimized for moving data between different parts of the system. It's kind of like having a dedicated high-speed lane just for parcelable objects.
Oh, I like that. So parcelable is more like sending a carefully packaged express shipment, while serializable is more like sending something through standard mail.
Yeah, that's a great analogy. And because this packing and unpacking process is so tightly controlled and optimized, it can be significantly faster, which can really make a difference in how smoothly your apps run. And hey, if data is being transferred frequently, it can even save battery life, since the phone's processor doesn't have to work as hard.
Right, so it's a win-win for both performance and battery life. So let's say a developer decides to go the parcelable route. What are some of the key parts involved in actually packing and unpacking an object this way?
Okay, so there are a few key components to making an object parcelable. First off, you've got this method called write to parcel. This is where the developer steps in and tells Android exactly how to pack the object's data into that parcel container. It's like writing a detailed set of instructions. Take this variable, put it here, convert this value to this format, and store it over there.
I see. So it's like creating a custom blueprint for how to disassemble and reassemble the object.
You got it. And then on the other side, when it's time to recreate the object, there's a special constructor that knows how to read from a parcel and use that data to piece the object back together.
So it's like a two-sided process. Clear instructions for taking it apart and clear instructions for putting it back together.
Exactly. It's all about ensuring that the data is handled correctly and efficiently during this transfer process.
Now, I'm looking at our notes here, and I see something called describe contents. What does this do for you?
Right, so describe contents is a bit more specialized. It's basically used to tell the system if your parcelable object contains any special types of data that might need extra care when being transferred. For example, if it contains things like file descriptors, which are like handles to files, the system needs to know that so it can handle them appropriately. In most cases, though, describe contents just returns 0, indicating there's nothing too fancy going on.
So it's kind of like a flag to signal if there are any delicate items in the package.
Exactly. In most cases, it's just a formality, but it's there for those special situations.
Okay, and then there's this thing called the creator. What's that all about?
The creator. It's kind of the unsung hero of parsable. It's basically a static field inside your parcelable object that acts as a factory for creating new instances of that object from a parcel.
Factory.
Yeah, think of it like a specialized assembly line that takes a parcel filled with data and spits out a brand new, fully formed object.
I like that analogy. So the creator is responsible for bringing parcelable objects back to life after they've been packed up and moved around.
Exactly. It's how Android knows how to take that raw data in the parcel and use it to build a fresh copy of the object. It has 2 key methods: create from parcel, which does the actual object creation, and new array, which is used to efficiently create multiple instances of the object if needed, like if you're working with a list of parcelable objects.
So it's a really crucial part of the whole parcelable process.
Absolutely. Without the creator, you wouldn't be able to resurrect those carefully packed objects.
Our notes also mention something called G01 parcelable and using parcelable objects with something called Android intents. What's all that about, and how does it connect to what we've been talking about?
So G01 parcelable probably refers to a code example in our resources that shows how a developer would actually write the code to make an object parcelable. It would give you a concrete look at how this whole process works in practice.
Oh, okay. So it's a practical example of how this concept is applied in real Android code.
Exactly. And Android intents are a fundamental way that different parts of your phone's software communicate with each other.
Okay.
Whether it's different screens within the same app or even different apps entirely, intents are used to pass data around. Think of them like messages that can carry information between components.
So if you want to, say, share a photo from your gallery app to a social media app, you'd use an intent for that.
Exactly. And if an app wants to send a custom object through an intent, that object needs to be prepared for this kind of transfer. By making that object parcelable, the app ensures that the data can be efficiently packaged and sent without bogging down the system.
So that's where parcelable really shines. It's the preferred way to send complex data between different parts of the Android system because it's so fast and efficient.
Precisely. It's all about providing a smooth user experience, and parcelable is a key part of that.
Awesome. Okay, we've tackled these powerful ways of saving complex objects, characters, settings, all those intricate things. But what about simpler data? Like those little preferences you tweak in your apps. That's where property files, also known as shared preferences in the Android world, come into play, right?
Right, exactly. They're kind of like a lightweight storage system for those little bits of information that personalize your app experience.
Like your preferred language, or whether you've opted into dark mode, or maybe even your high score in a simple game.
Exactly. Shared preferences are perfect for those kinds of things. Think of them like a simple key value store.
Key value, what's that?
So imagine a physical notepad where you write things like language, English, or dark mode, on. Each of those settings has a key, like language or dark mode, and a corresponding value, like English or on. Shared preferences work in a similar way. They allow an app to store these simple pieces of data associated with specific keys so it can easily retrieve them later.
So it's a way for the app to remember your preferences and settings even after you've closed it or turned off your phone.
Exactly. It's all about persisting those little bits of customization that make the app feel more like yours.
Okay, so it's not for saving complex game states or entire documents, but more for those smaller settings and options that tweak how the app behaves.
You got it. Think of it as fine-tuning your app experience. And one important thing to know about shared preferences is that they have a limited scope. They can be specific to a particular part of an app, like a single screen, or they can be shared across the entire app, depending on how the developer sets things up.
So there's some flexibility there in terms of how broadly those preferences apply within the app.
Right, it's all about choosing the right scope for the specific setting.
And what kinds of data can actually be stored in these shared preferences?
We're talking about basic data types. Booleans, which are just true or false values, floats for decimal numbers, integers for whole numbers, and longs, which are basically just larger whole numbers.
So it's really for those fundamental pieces of information, not complex objects like what we talked about with serialization.
Precisely.
Okay, so how does an app actually work with these shared preferences? How does it get access to them and then save and retrieve your settings?
All right, so there are a few ways an app can get its hands on a shared preferences object, depending on what it needs. The most general way is using the get shared preferences method, which is accessible through what's called a context in Android. Think of a context as the app's way of interacting with the Android system and getting access to resources. So, using get shared preferences, the app provides a name for the preferences file it wants to work with. It's like giving a label to its little notepad of settings. And then it typically specifies that this file should be private, meaning only this app can access it.
So each app has its own set of preferences that are kept separate from other apps.
Exactly. It's all about keeping things tidy and secure.
Now, our notes mention another method called get preferences. When would an app use that instead?
So get preferences is a bit more specialized. It's available in something called an activity, which is basically a single screen in an app.
Okay.
And when an activity uses get preferences, it automatically gets a shared preferences file that's specific to that particular screen. It's like having a separate notepad of settings just for that one part of the app. So if you have some settings that only make sense within a specific screen, the developer might use this method.
So it's a way to keep things organized and only load the settings that are relevant to what you're doing in the app at that moment. And what about get default shared preferences? From something called a preference manager. When would an app use that?
Yes. Get default shared preferences. This is often the go-to for app-wide settings.
Well,
it gives the app access to a single shared preferences file that can be used from anywhere within the app. So settings like your chosen language, or whether you want dark mode, enabled, those kinds of things that apply to the entire app experience, they're often stored using this method.
So no matter which screen you're on, the app can access those global settings.
Exactly. It's a convenient way to manage preferences that affect the app as a whole.
So the app's got this share preferences object, this little notepad.
Yeah.
How does it actually save and then get back your chosen settings?
All right, so to make changes to the preferences, the app first needs to get what's called an editor.
An editor.
Yeah, it's kind of like checking out the notepad so you can start writing in it.
Okay.
The app gets this editor by calling the edit method on its shared preferences object. Then it uses the editor to make changes like adding new settings or updating existing ones.
And how does it actually store those settings with their keys and values?
Android provides a bunch of convenient methods for this, like put boolean, put float, put in, and put long.
So you use the method that matches the type of data you're saving.
Exactly. You pick the right tool for the job.
Okay, so you call, say, putin to save a whole number, like the volume level you've set, and you provide the key, which is like the label for that setting, and then the actual value.
Precisely. It's like writing volume 75 in your notepad, where volume is the key and 75 is the value.
And then to retrieve that setting later, you just use the corresponding get method.
Right. So to get that volume setting, you'd call getInt and provide the key volume.
And it would give you back the value 75.
Exactly. It's like looking up an entry in your notepad.
Okay, so far so good. But there's one really important step the app absolutely must do to make sure those settings are actually saved permanently.
Yes, you're talking about the commit method.
Right, so it's not enough to just call those put methods, you have to call commit afterwards.
You got it. Think of commit as actually saving the changes you've made to the notepad. If you just write in the notepad but don't save the file, those changes could be lost. Really.
Oh, like when you forget to hit save on a document and it crashes and you lose all your work.
Exactly. Same idea here. So after making any changes to the shared preferences, the app needs to call commit on the editor to ensure those changes are written to storage and won't disappear if the app closes or the phone restarts.
So it's a crucial step like hitting the save button.
Absolutely. It's the difference between your preferences being remembered or potentially vanishing.
Now, I'm seeing a few other methods here related to the editor. Remove and clear. What do those do?
So remove is for deleting a specific setting based on its key.
Okay.
If you decide you no longer want to store a particular preference, the app can use remove to get rid of it. And clear is the more drastic option. It wipes out all the settings in that particular shared preferences file, like clearing the entire notepad.
So it's like starting fresh with a blank slate.
Exactly. And just like with the put methods, the app must remember to call commit after using remove or clear to make those changes permanent.
Gotcha. Commit, commit, commit. Don't forget to hit save.
Exactly. It's the golden rule of shared preferences.
And we have another one of those cryptic G references, G02, shared preferences. What's hiding behind that, do you think?
That's probably another code snippet in our resources that gives a practical example of how an app might actually use shared preferences. It might show how to get a shared preferences object, use the editor to save different types of data, and then retrieve those values later. It would be a concrete look at how all these little settings you tweak in your apps are actually managed behind the scenes.
Oh, that's helpful. It's always good to see how these concepts are put into practice.
Definitely.
Okay, so we've covered how apps save simple settings. But what about when they need to store bigger things like files? That's where internal storage comes in, right?
Right. Internal storage is like each app's own private little world within your phone's memory.
Their own little sandbox to play in.
Exactly. Each app gets a dedicated area where it can store files that only it can access. It's like having a private folder that's completely walled off from other apps.
So if app A saves a file to its internal storage, app B can't sneak in and peek at it, even if they're both on the same phone.
Exactly. It's all about privacy and keeping data separate.
And what kinds of files are typically stored in this internal storage?
It's usually stuff that's essential to the app's functionality, but doesn't need to be shared with other apps, things like databases, caches, or even files that store your progress in a game. It's the app's own internal workspace.
So it's not for things like photos or videos that you might want to share with other apps or access outside of that specific app.
Right.
And what's the lifespan of files stored in internal storage?
Well, the key thing to know is that when you uninstall an app, all the files it has stored in its internal storage get deleted along with it.
Oh, so it's like a self-cleaning system. If you remove the app, all its private data goes with it.
Exactly. It's a way to keep your phone clean and prevent apps from leaving behind a bunch of orphaned files that you no longer need.
So how does an app actually go about saving and reading files within its own little internal storage area?
Okay, so to save a file, the app uses a method called openFileOutput. It gets this method from its trusty context, and it needs to provide two things: the name it wants to give the file and a mode, which usually is context.mode or private.
Okay, so mode or private just reinforces that this file should be kept private to the app.
Right, it's like putting a big keep out sign on the door.
And what does openFileOutput actually return?
It gives back something called a file output stream.
A stream.
Yeah, think of it like a pipeline that the app can use to write data into the file.
Okay, so it opens this pipeline, this stream, and then just starts pumping data into it, the raw bytes that make up the file.
Precisely.
And then on the flip side,
Yeah.
when the app wants to read that file back, what does it do?
It uses a similar method called openFileInput, again providing the name of the file it wants to access.
And this gives back a file input stream.
You got it. It's the pipeline for reading data from the file. And if the file contains text, the app might wrap this file input stream in something called a buffered reader, which makes it easier to read the file line by line like you're reading a document.
Oh, so it's like adding a convenient interface on top of that raw data string.
Exactly. It makes it much easier for the app to work with text files.
And I see our notes mentioned another G reference, G03, Feasier in turn.
Ah, yes, that's probably an example in our resources that shows how an app might actually use these methods to read and write files within its internal storage. It might demonstrate saving some text to a file using openFileOutput, then reading that text back using openFileInput, possibly with a buffered reader thrown in for good measure.
Right, so it would be a concrete illustration of how these concepts are applied in real Android code.
Exactly.
Okay, we've talked about internal storage, which is all about privacy and each app having its own little space. But what about external storage? That's where things get a bit more, well, external, right?
Right. External storage is like the shared public park of your phone's storage system.
The communal space where everyone can hang out.
Exactly. Unlike internal storage, which is all private and app-specific, external storage is accessible to multiple apps and even to you directly, through a file manager or by connecting your phone to a computer.
Right, so this is where things like photos you take with the camera app, music you download, or other files you might want to share between apps or keep, even if you uninstall an app, This is where those things usually live.
Precisely. It's the go-to place for data that needs to be more broadly accessible or that you want to keep, even if you decide to remove an app.
So, more freedom, but also potentially more risk, I imagine, if multiple apps can access this space.
That's where permissions come in. It's a really important concept when we're talking about external storage.
Right. Our notes mention permissions quite a bit in this context. So what's the deal with permissions and external storage?
To put it simply, an app can't just go around reading and writing files on your external storage willy-nilly.
It needs your permission.
Exactly. There are actually two levels of permission involved. First, the app has to declare in its manifest file. That's kind of like the app's ID card that tells the system what it's allowed to do. It has to declare that it might need access to external storage.
So it's like raising its hand and saying, hey, I might need to access this shared space.
Exactly. But that's just the first step. More importantly, for newer versions of Android, starting with API level 23, the app also has to ask you, the user, for permission at runtime.
Oh, so it's not just a one-time thing. It has to ask permission every time it wants to do something on your external storage.
Not necessarily every time, but the first time it needs access, it has to ask. And you, as the user, have the power to say yes or no.
Ah, so you're in control. You get to decide which apps can access your files on external storage.
Exactly. It's a really important safeguard for your privacy. And it's worth noting that these permissions are granular. An app might request permission to read from external storage, write to external storage, or both, depending on what it needs to do.
Okay, so permissions are all about ensuring the user is in the driver's seat and gets to choose what apps can access their files. But what about just checking if external storage is even available at a given time? I mean, someone might have removed an SD card or something.
Right, that's a really important point. Before an app even tries to do anything with external storage, it needs to check if the storage is actually there and ready to be used.
Makes sense. So how does an app check that?
Android provides this handy method called getExternalStorageState. It's a simple way for the app to ask the system, hey, what's the status of the external storage right now?
And what are some of the possible answers the system might give?
The system returns a string that tells the app the current state, and there are a few key ones to be aware of. Media mounted is the ideal scenario. It means the external storage, whether it's an SD card or some portion of the internal storage designated as shared, it means it's present and fully accessible for both reading and writing.
So it's like a green light. Go ahead, do your thing.
Exactly, but there are other states too. Media mounted dreadingly means the storage is there, but the app can only read existing files. It can't save any new ones.
Okay, so that's like a yellow light. Proceed with caution.
Right. Then there's median mounted. This means the storage is physically present, but it's not currently connected or ready for use.
Like it's there, but not quite online yet.
Exactly. And lastly, there's media removed, which means, well, the external storage has been removed, like an SD card being taken out of the phone.
So that's like a red light. Stop, do not pass, go.
Yeah, pretty much. And the app needs to gracefully handle all of these different states to avoid crashes or data loss.
It makes sense that an app would always check the state before doing anything with external storage.
Absolutely. It's a fundamental best practice.
Okay, so the app knows if external storage is available and has gotten the necessary permissions. What about actually finding the right place to save files?
Well, that depends on what the app is trying to do. If it wants to save files in a standard, well-organized location that other apps and the user can easily access, it can use a method called getExternalStoragePublicDirectory.
Okay.
This method takes a special identifier that specifies the type of directory the app is looking for, things like environment.directory pictures for photos, environment.directory music for music, environment.directory downloads for downloaded files, and so on. It's like asking the system, hey, where's the official public directory for this type of file?
And this helps keep things organized and consistent across different apps.
Precisely. It ensures that all your photos end up in the Photos folder, all your music in the Music folder, and so on. It makes things much easier to find and manage.
Now, our notes mention the environment class quite a bit. What role does that play in all of this?
The environment class is kind of like a central hub for information and utilities related to the external storage and other aspects of the file system. It provides methods for things like checking if the external storage is removable, getting the current storage state, and also obtaining file objects that represent different directories on the device.
Oh, so it's like a toolbox for working with files and directories.
Yeah, exactly.
And what are some of the other useful methods or directories provided by this environment class?
Well, there's get_root directory, which gives you the root directory of the entire file system, but that's usually not something apps need to work with directly. More commonly, you have get data directory, which points to the directory where app-specific data is stored, though usually apps prefer to use their private internal storage for that.